Welcome back, guys. So in this particular video, we are going to be talking about the fundamental examples of sets and set listing. So let's start with the first one, fundamental examples of sets. If we are talking about the fundamental examples of sets, this is where we are going to be talking about natural numbers, integer numbers, rational numbers, real numbers, and complex numbers. What are the differences between all these numbers? What are the relationships between all these numbers? That is what we want to talk about now. So let's start with the first one, which is natural numbers. Natural numbers. What are natural numbers? You have to know that the natural numbers are always denoted by this capital N. So this simply means that wherever you see N in set theory, we are talking about what? Natural numbers. Then what are natural numbers? You have to know that natural numbers are numbers that are natural. You are shocked? Don't worry. So you are talking about numbers that are natural. These are numbers that start from 1 till infinity. So this simply means that natural numbers start from 1 to infinity. So this simply means that any number from 1 to infinity can be referred to as what? Natural numbers. So 0 is not a natural number. Then let's talk about the first one, integer numbers. Integer numbers. So guys, if you're talking about integer numbers, they are always denoted by capital Z. So this simply means that whenever you see capital Z, it's talking about what? Integer numbers. Then what are integer numbers? So before I'm going to talk about integer numbers, you have to understand that integer numbers can be subdivided into 3. Basically into 2, but I'm going to just let us say 3. So the first one is that we have the positive integers, we have the negative integers, and we have the neutral number, which is 0. So this simply means that whenever we are talking about integer numbers, we are going to be considering two things. We are going to be considering two things, positive and negative, including 0. Are you there with me? So this simply means that any number that is coming from negative, from minus, like minus 10, minus 9, minus anything minus is integer number. So minus 4, minus 3, minus 2, minus 1, 0. To the positive, plus 1, plus 2, plus 3, plus 4 till infinity. So this negative side are the ones called the negative integers. Negative integers. We can call this 0 as neutral number, but from the positive, yeah, we can refer it to as positive integers or natural numbers. So guys, if you get the scope behind this now, you will see that natural numbers are numbers starting from 1 to infinity. But integer numbers can either be positive number or negative number, including 0. So this simply means that the positive numbers are referred to as the positive integers, while the negative numbers are referred to as what? Negative integers. So you will now see that the positive integers starts from 1 to infinity. Also, natural numbers start from 1 to infinity. So that is why positive integers can also be referred to as what? Natural numbers. Are you there? So any number that starts from 1 to infinity can be referred to as natural numbers or positive integer. So this simply means that we can say something, that all natural numbers are present in integer numbers. Are you there? But all integer numbers are not present in natural numbers. Then let's talk about the third one, guys. Rational numbers. Rational numbers. Rational numbers. Guys, the representation for rational number is actually Q. Are you there with me? So you have to know that these rational numbers can also be referred to as fractional numbers. Fractional numbers. So we also refer rational numbers to as fractional numbers, and this simply means that these are numbers that can be written in the fraction form like this, A over B. So rational numbers can also be referred to as fractional numbers, and there are numbers that can be written in what? Fractional form like this. So what are the examples of rational numbers? The examples of rational numbers include, let's say 2 over 5, 4 over 3, 2. The reason why 2, 5 can also be rational number, the reason why is because all the integer numbers that we have here, we can always write them in fractional form. We can always write all integer numbers in what? Fractional form. For example, 2 is an integer number. We can write it in fractional form as 2 is the same thing as 2 over 1. So any number that can be written in fractional form can be referred to as what? Rational numbers. Are you there with me? So 2 is a rational number. 5 is also a rational number because it can be written in what? Fractional form. Also, guys, minus 3 is a rational number because minus 3 is the same thing as what? Minus 3 over 1. So this simply means that we can say that all integer numbers are rational numbers because all integer numbers can be written in what? Fractional form. You will now ask me that what of 0? Yes, 0 is also a rational number because 0 can also be written as 0 over 1. 0 over 1 is something as what? 0, yes. But 1 over 0 is undefined. Why 0 over 1 is still 0? So this simply means that all integer numbers are rational numbers. So if you are following now, this simply means that all natural numbers are integer numbers. All integer numbers are rational numbers. Are you there with me? So we can also say 2.5 is also a rational number because 2.5 is the same thing as 2.5 is the same thing as what? 5 over 2. So that is about what? Rational number. So any number that can be written in fraction form, in the form of a over b, that number are referred to as what? Rational numbers. So, but before we move on to real numbers, we have to understand something that we call the irrational numbers. What are irrational numbers? Irrational numbers are numbers that cannot be written in the form a over b. And the simplification of irrational numbers always extends to infinity. Are you there? So this simply means that there are some particular numbers that cannot be written in this fraction form. Are you there? They cannot be written in fraction form. Any number that cannot be written in fraction form are simply referred to as what? Irrational numbers. And whenever we simplify this irrational number in their decimal form, the value we usually get is always long till infinity. What are the examples of irrational number? The examples of irrational number include pi, e, root 2, root 3, root 5, root 6, root 7, root 8, root 10, etc. So, pi is an example of irrational number because when you press pi on your calculator, the value you are going to get, you will see that the value will be very long. So whenever we get whenever we try to simplify a particular number and the value we get extends to infinity, those numbers are what? Irrational numbers. So e, which is natural log, is also an example of what? Irrational number. Because if you also press E on your calculator, the value you are going to get will also extend to infinity. Now you will see that I did not write 1. I did not write root 1. Because if I should write root 1, the simplification of root 1 is going to give me 1. Are you there? So this simply means that root 1 is not an irrational number. But if I should press root 2 on my calculator, the value I'm going to get is going to extend to infinity. You are going to see that if you should press root 2 on your calculator, the value you are going to get will extend to infinity. So that is simply why root 2 is what? Irrational number. The same thing, if I should press root 3 on my calculator, the value I'm going to get in decimal form will also be very long. It also extend to infinity. So that simply means that root 3 is also what? Irrational number. But if I should press root 4 on my calculator, what am I going to get? I'm going to get 2. Are you there with me? So this simply means that root 4 is not an irrational number, but root 4 is a what? Rational number. The same thing as root 5. If I should press root 5, root 6, root 7, root 8 on my calculator, the value I'm going to get will also extend to infinity. But if I should now press root 9 on my calculator, I'm going to get 3. So this simply means that root 9, root 4, root 1, they are not a rational number. But root 2, root 3, root 5, root 6, root 7, root 8 to root 10, they are what? A rational number. So the next thing you now have to note is that odd numbers. Now, let's talk about the real numbers, guys. Let's talk about the real numbers. The real numbers. Real numbers. We usually represent real numbers as capital R. Idea. So we can say that all numbers belonging to rational and irrational numbers are real numbers. Are real numbers. So this simply means that all the example that is under these rational numbers and irrational number, if you combine all the examples together, those numbers can also be referred to as what? Real numbers. So that about that. So for natural numbers, they start from 1 to infinity. For integer number, there can be positive numbers or negative number or 0. For rational number, there are numbers that can be written in fractional form of a over b. While for irrational numbers, there are numbers in which, if you should simplify them in their decimal form, the value we are going to get is going to be very long. It's going to extend to infinity. While real numbers are all the numbers that belongs to rational numbers and irrational numbers. Combine them together, those are what? Real numbers. So this simply means that natural numbers belong to integer numbers. Sorry, all natural numbers are integer numbers. All integer numbers are rational numbers. Why also all rational numbers are what? Real numbers. Then let's talk finally about the complex number. Now, guys, let me add one more. Counting numbers. Counting numbers. So let's talk about complex numbers and counting numbers, guys. We have said that natural numbers are represented by n, integer numbers represented by z, rational numbers represented by Q, real numbers are represented by capital R. So counting numbers are also represented by capital C. Sorry, complex number. So guys, let's talk about complex number. What are complex number? Don't stop yourself. Complex numbers are numbers that are complex. Oh, that does it. Complex numbers are numbers that are what? That are complex. You know that when something is complex, that simply means that that thing cannot be simplified easily. That's it. That's it. Yes. So complex numbers are numbers that are complex. But how are we going to be able to identify complex numbers? How are we going to be able to identify that this particular number is a complex number? You have to tell something that all complex numbers always take the form of a plus bi. This simply means that all complex numbers are always written in the form of a plus bi. Guys, you see a and b, they are real numbers. Real numbers. By now, you already know what real number means. Real numbers are numbers that can be rational or irrational. So a and b, they are what? Real numbers. A and b are real numbers. Then what is this I? This I is equals to root minus 1. So this simply means that what actually makes a particular number to be complex is the presence of this I. And what is the representation of this I? This I is equals to square root minus 1. If you should press square root minus 1 on your calculator, it's going to give you cancel. Either or it gives you math error. Because what? This I is a complex. Either. So whenever you want to identify a particular number, before you can say that if this particular number is a complex number, then you must see that there is I there. So this I is what makes a number to be complex. Are you there with me? Yes. So this simply means that you have to understand something, guys. What you have to understand is that, you know, I've already said that A and B are real numbers, right? So then this simply means that you also have to know that A is also referred to as the real part, and B is referred to as the imaginary parts. Imaginary parts. So the A here is referred to as a real part, while the B, which is the coefficient of I, is referred to as what? Imaginary part. Then what are the common examples of complex number? The common examples of complex numbers are 2 plus 3i, root 2 plus 4i, 0 plus 3i. So what we are just trying to tell you is that whenever a number will be representing a complex number, there must be presence of I. The presence of I. So this simply means that I is what makes a number to be complex. I is what makes a number to be complex. So the next, all real numbers can also be written in complex form. You know that some examples of real numbers is 3. 5 can be written as 5 plus 0i. So that simply shows that all real numbers can be written in what? Complex form. You will just add plus 0i. Because 0 times I will still be 0. 3 plus 0 will still give us 5. 3. Right there. So that is that about what? About that. So this simply means that what you have to understand now is that all complex number can be, all real numbers can be written in what? Complex form. Then before we move on to counting numbers, you have to note something. What you have to note now is that is N is a subset of Z, is a subset of Q, is a subset of R, is a subset of C. What does it mean? Before you can say you want to understand what this expression is, you firstly have to this number. What is Z? Z are integer number. What is Q? Q are rational number. What is C? C is for complex number. So you can understand what this expression means. You must firstly understand what is N. N is natural number. What is Z? Z is numbers. What is R? R is real numbers. And what is C? C is complex number. Then what does it mean? This simply means subset. And what is that expression talking about? The expression is talking about that are integer numbers. All integer numbers are rational numbers. All rational numbers are real numbers. All real numbers are complex numbers. That is what the expression is talking about. That is, all the elements in natural numbers belongs to integer numbers. All integer numbers can be written as rational numbers. All rational numbers also belongs to real numbers. All real numbers can also be written as what? Complex number. That is what the expression is talking about. So you must be used with the expression and don't confuse this with each other. Number. What is counting numbers? Now let's talk about a counting number. What is counting number? Counting numbers are numbers that start from 0 to infinity. Now you will now be wondering that what is the major difference between counting numbers and natural numbers? What you have to understand is that natural numbers start from 1 to infinity, while counting numbers start from 0 to infinity. You can see that the difference between natural numbers and counting number is just what? Is just 0. So in natural number there is 0, in number there is 0. So let's talk about the listing of sets. Let's talk about the listing of sets now. Set listing.